study in this chapter is various natural phenomena, okay, which is there in your course. Okay, natural phenomena like say why sky is blue.
Sir, formation of rainbow.
Yeah, okay. Formation of rainbow.
Twinkling of stars.
So advanced sunrise and delayed sunset.
Comets.
What comets? Say some line. Apparent position of star, which includes your sunrise sunset concept. Okay. Okay. Anything else? You have your sky is blue and Tyndall effect will be doing there itself, I think. Okay. So these are the natural phenomena what you have to understand in detail. Understanding rainbow is one of the most difficult one. Okay. So we'll see whether we'll pick that up today or not. So can you tell me what are the underlining concept behind these ones? Like why sky blue?
That's
Because of
the
certain phenomena
I
you have
guess.
what you have already
Scattering.
studied. Yeah, it is because of scattering, right? Right. So scattering is what we have to learn if we have not learned yet. Have we learned yet scattering? No, not done, right? Why? What would rainbow involve? What happens to light such that rainbow happens?
Refraction of light.
Dispersion of light.
Yeah. So dispersion we have to study, right? So it involves dispersion and other things also. Can you tell me what are the things? What are the things it involves?
So internal reflection of the light.
So it involves reflection, okay. And what else? Refraction, right? So dispersion is there, refraction must be there, right? Right? So of which we know what's the reflection, we know what's the refraction, right? So dispersion, I'll just quickly go through if you have not done. Have you done dispersion, guys? No, right? Okay. Twinkling of star, what is that involving? Anybody? What might that be involving? Which?
So atmospheric attraction.
Yeah, correct. So it is again involving what? Refraction, right? Refraction. So refraction we already know. So we'll discuss that. Apparent position of star. It is involving again refraction, right? Get the point? So what are the two new concepts what you see over here? What are the two new ones? One is scattering, which we have not done in Neev yet, and one is dispersion, right?
Dispersion.
So today we'll start with dispersion and then we'll do scattering so that we know what all these mean, and then we'll start picking up each natural phenomena what you are observing. And what is the chapter called? Beautiful world or something, right? Human eye and the beautiful world. Beautiful world. Does it say?
Colorful world.
Oh, colorful world, huh? Okay. So this colorful world thing, we'll just start picking the easiest ones. We'll see which is the easiest one and then go forward. So dispersion, okay. First one is dispersion. Anybody, any idea what is dispersion? Would you like to speak? Would you like to say
Sir,
something?
light splits into
Not like this
different.
way. You have to tell your name. If I hear your name, I'll call back your name and then you can speak. Okay, is that rule clear?
Yes, sir. Dhruva.
Dhruva. Yeah, Dhruva, tell me.
Sir, white light splits into its constituent color lights.
Yeah, Dhruva, a lot of noise is coming from your side. So next time you speak, you just ensure that there is silence on the other side. Okay, white light splits into its constituent colors, right? So if he's saying constituent colors, can anybody tell me what does it mean by constituent colors?
So Vibgyor, like the combination of colors, those colors form other.
So
Full spectrum of the wavelengths.
Yes.
why they are the only colors or what?
No, sir, they represent the spectrum of wavelengths that white light disperses into.
Okay. Anybody else? Any other comment on that? So we'll just quickly do what is your wavelengths or what are the constituent colors as he's saying. So I'll do it in black so that we can look at the white light. Okay. So is this lower line clear? Rest I'll redraw and all. Is the lower line clear?
Yes, sir.
Okay. Yeah, so suppose that's a white light. That is white light. So what do we mean by white light? Like what is white over here? Do we see white? Anything? Do we see light?
No, sir.
We can't see light, right? What do we see? We see objects, right?
You see the object that light is reflected off.
Yeah, so we don't actually see light. That part is very clear to you, right, guys? Right? Okay. So a light is electromagnetic waves, and those waves have different wavelengths. So is that part also clear, or we have to describe that? That's also clear, or we have to describe that?
So could you describe it?
Okay. In ninth, do you remember waves? You have done some mechanical waves. Do you remember the waves? Guys, what are waves? What are waves, guys? Anybody?
So reflection of crescent troughs.
Yeah, waves were something like a disturbance which is traveling, right? Right? Right?
Yes, sir.
So light is also a disturbance in the electric field and magnetic field. What do you mean by electric field and magnetic field? This part is, you don't have to understand very well, but have just a vague idea of what I'm saying. If there's any charge, it has got in the vicinity or in the area around it. It goes till infinity, by the way, but in the area around it, it has its maximum effect. That area what it affects is called the field of that charge. Is that clear? Like masses have what kind of field around it? Gravitational field, right? So it goes till infinity, but obviously near to it is the major effect, right? Right? If you keep another mass, another mass will get affected by the gravitational field. In the vicinity of a charge, if you keep another charge, then what is going to happen? That charge is going to get affected by the field of this guy, right? The other charge, right? And will experience a force, right? Is that clear? So at a very micro level, those kind of things are actually going to happen to explain you what is scattering, but we are not going to go in that detail initially. When we are done with our school level stuff, then we can actually go into how it absorbs and re-emits, which is not there in your school requirement at all. So we'll just put things very simply initially, okay, in terms of scattering and in terms of field and all. But very simple idea of what's the electric field. Electric charge has got electric field around it, right? 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 What is magnetic field? What is magnetic field? So in a very simple way, if I have a magnet, say North Pole, South Pole, then it has got a field around it, right? Those are magnetic fields,
Yes, sir.
right? The genesis of the magnetic field may be through the electric field or vice versa. That is higher study. Again, we are not going to discuss that right now. So we just think of three fields in a very classical way, that you have masses which have gravitational field. If you have magnets, you have magnetic field around it, and it will, those magnetic field will affect another magnetic substance. If you have charges, it will have electric field and it will affect other electric substance, right? So what is light? Light is a disturbance in electromagnetic field. Is that clear? If the field is growing high and low, high and low, high and low, okay? If the magnetic field is becoming high and low, high and low, high and low, okay? Okay? Periodically it is becoming high and low, then it is a certain disturbance, right? And I can just represent that the electric field became high and low and high and low. Is that clear? Is that clear? But it is not so simple. It is in fact having a magnetic field also. So simultaneously magnetic field is also becoming high and low, high and low. Is that clear? Is that clear? Is that clear?
Yes, sir.
So the representation is not required for you right now. The knowledge that it is an electromagnetic field is required. Okay, they just want you to know the word, and they don't want you to care much about it. But if you start caring, it is good for you. Not like it is going to bring any marks difference in your school exam. Is that clear? Is that clear?
So basically,
So if it is an electric field or a magnetic field which is traveling like a disturbance, then it will have a certain wavelength, right? 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 It became high and low and back again high. In how much time? Say in t time the disturbance became high, or from high it went to low and came back to high position. Okay, high value. Then the time is called, somebody tell me how much is that time called? How much is the time called? The disturbance goes from any given point, say a high point, then goes to the lowest and come back to that high point again. What is that time called? It has got a special name. Anybody? Anybody? Ayo. Remember your sound waves?
yes, sir.
A molecule is going, say, right, and then comes back. It is going this way, so this is not back to the same state. Again goes to the extreme left and comes back to here. What is this time called? Total time called?
So is it period?
What?
Wavelength.
Period.
Time will be called wavelength. That's quite odd to hear itself, no? How can time be called length, guys? That's very odd to say, right? Or it goes
Is
from
it
here
period?
till there and comes back. Any position I can start, but it has to come back to that in the same sense. Yeah, tell me properly, what is it called? I'm little disappointed over here. I don't think like this would be a word anybody would be missing. A pendulum. Okay, let me just get to a very basic mechanical wave. Sorry, not a mechanical wave, but an oscillation. Pendulum goes here, goes to the extreme, comes back to this. What is this time called? Goes, returns, and comes back to the extreme.
Oscillation.
What's the time called? Not like what is the process called?
Frequency.
What's the time called? How can time be called frequency? Frequency is frequency. Frequency is how many times it does that. Okay. How many times something will do that in a given, say, time length or something. Okay. I'll come to the frequency term. But what is this time of an oscillation called? I know you know it. It's just not coming out of your mouth. What is it?
That's someone wrote period.
Time period, right? Yeah, somebody told period, not time period. That's a very specific name. So what is time period? What is time period? Any disturbance from any given point, it is going to some other state, some other state, some other state, and comes back to that same state. That is called one time period. Okay, the time taken to complete one oscillation. Oscillation, you may imagine, is starting from here and then ending over here. It's again the same time. In a very fancy way, you can imagine the oscillation starting over here. It has to come back to that again. That is also one oscillation, right? Right? Generally, people start counting from middle and back to the middle, okay, or extreme and back to that extreme, right? This is called what? One time period. Is that clear?
Yes, sir.
In that one time period, how much the wave goes forward is called what? Is called what? If you don't know these things, you can write it, not specifically required for this chapter, but as a knowledge you should have this, because it has been done in class 9, so they expect that you know this. The length it goes forward, I'm giving you big hint by the words I'm putting, okay? The length it goes forward in one time period is called what? What goes forward? The wave goes forward, the disturbance goes forward. Like a air molecule is doing its own oscillation. That is not going forward. But while it is doing its oscillation, the whole disturbance has gone forward, right? This part was still, but it has started getting disturbed while this was doing its oscillation. What is that thing called? While a molecule is doing its oscillation, the whole disturbance has gone forward. How much length? In one time period, the length gone forward is called what?
So wavelength.
That's called wavelength, right? Wave is the disturbance and the length gone forward in one time period. So remember that, right? Because I know in some places they'll teach the same thing in a very different way or something, and sometimes you kids, you guys have a very fancy idea of what is a wavelength. So what is wavelength? And this wavelength is just a representation. It's not like something is going like this. Is a particle going like this in a wave? Obviously not. You look at even if you are looking at the ripple on top of water and the ripples look like this, are the particles going like this? No, right? You catch a hold of any one particle, it is just going up and down, right? Right? Right?
Yes, sir.
You know that, no?
Yes, sir.
You keep a piece of paper over here, it just goes up and down, right? Right? So the time in which it completes one round is your time period, and in this time the disturbance could go how much forward is called one wavelength. Is that clear? Which
Yes,
will
sir.
happen to be like if you take it from the peak to peak and all, okay? So can we say wavelength represented by the letter delta? Can we say it is the speed of the wave into the time, because speed into time gives you the length traveled, right? Right? Right, guys?
Yes, sir. So
Yes.
wavelength is velocity by frequency, right? The formula for
Yeah, whatever is the formula, I don't know so many formulas. I'm just asking you that if I am defining that the time in which the particle took one round, which I am calling it as capital T, how much is the length or how much is the distance traveled by the disturbance, where the speed of the disturbance is given as c. C is the speed. Are you understanding? So if c is the speed of the disturbance, while this particle was taking one round in capital T time, how much did the disturbance go forward by? So we have that age old formula, no, with us. If there is no acceleration and all, your distance traveled is equal to
speed into time.
speed into time. We know that, right? Holds good if there is no acceleration, right? This formula holds good, right?
Yes, sir.
Right? So the speed was c of the wave or of the disturbance, right? Speed was that, right? And the time in which I am asking is what? The time period, right? Right? And I am calling this, the distance traveled by the wave in time period time is called as wavelength. So I cannot deny this equation, right? Can I? Because I am defining a wavelength like that. Is that clear? Is that clear?
Yes, sir.
which happens to be crest to crest, trough to trough and all. Okay, but understand the basic things. Are you understanding? Do you get it? Do you get it? Lalit sir is going to kill me because I am doing something else altogether. I'll just go on to the main part. Don't think it is going to matter in your this class understanding much, but these are basic things. So you can call, instead of the heading as dispersion, what can you call this as? Basics of light, right? Is that clear, guys? Is that clear?
Sir?
No. Let me just go on. Yeah, ask first.
Sir, so this formula what you gave is the same as the distance formula, right?
Yeah, distance traveled, length traveled
Yeah.
is length traveled by light in one time period is called wavelength. Length traveled by wave in one time period is called wavelength, right? Right?
Yes, sir.
And we are talking about light waves. Then what is the speed? It's a constant or not? It is the constant or not? Like it's the biggest constant of the world or not? Right? What is that? Speed of light, right? Roughly how much? 3 into 10 power 8 meter per second, right, guys? Right, guys? Right,
Yes.
guys? Okay. We also have a fancy new name. It's not new because you have been hearing this, which is frequency, right? Say I'll call it as F. Now, how do I define frequency as? In 1 second, how many times or how many rounds it has taken, how many oscillations it has completed in 1 second. Number of oscillations, you can write it if you want. In 1 second, in this 1 second, in not a time period and all. How many oscillations in one time period, by the way? How many oscillations in one time period? A wave takes how many oscillations in one time period? A particle takes how many oscillations in one time period? One oscillation, right? Because time period was one oscillation is being done in how much time period, right? So, a very simple question. Suppose the time period always given by the letter capital T. Time period is 2 seconds. Can you read it in an English sentence? What does it mean? Time period is 2 seconds. In a more elaborated way, can you read it out? What does it mean? Equations are equations. They are written that way. But when you look at an equation, your brain should be interpreting in a whole good, nice sentence in the most favored language of yours, which I guess is English. All of you are talking in English, thinking in English. Okay. In our generation, it was more of our mother tongues. But anyways, this time period is 2 seconds. What do you like? You don't call it as t is equal to 2 seconds, not at all. T is equal to 2, not at all. That is how some people think t equal to 2. Wrong, don't think. Your mind should not work like that. A better mind is t is equal to 2 seconds. This is also far from good. Even better mind is time period. It's written like this, but you have to read it out, whole thing in your head. Time period is equal to 2 seconds. Right? Even better is what? The meaning of time period should come in our mind, right? So what is this? What does it mean? What does it mean?
The time taken to complete one oscillation.
Absolutely. That is what you should be thinking. That is how you should be thinking if you have to handle your science in 11th, 12th and later on. Okay, so time taken to complete one oscillation is given as 2 seconds. Good for us. Okay, that is how you will read this. Good for us, that is given to us. Frequency is asked. Frequency is how much? This also you will read the whole thing in your head. What will you read in your head as? F is equal to how much? ऐसे नहीं read करोगे. क्या read करोगे? How many oscillations does it take in 1 second, right? Right? Right?
Yes, sir.
So the first line says it takes 2 seconds for one oscillation. It takes 2 seconds for one oscillation. The next line asks, in 1 second, how many oscillations? So what's the answer?
So 1/2 or half.
Yeah, half oscillation, right? Right? As simple as that, right, guys?
Yes, sir.
It
Yes,
took
sir.
it took 2 seconds to make this full round, right? So they are asking that in 1 second, where how much of a round did it take? It took only half a round, right? As simple as that, right? So frequency
Yes, sir.
must be 1/2 seconds or not, right? Somebody was doing a lot of work on your frequencies and sound, and his name was Hertz. So to honor him, 1/2 unit is called what? Hertz, right?
Hertz.
Right? So 1/2 seconds you can call, 1/2 unit is per second or Hertz. Is that clear? Is that clear? Is that clear? So we have a formula made out of it, right? If time period is capital T, your frequency will be what? 1/t, right? Right, guys? Same logic. Is that clear? If it takes t seconds to complete a round, then in 1 second it would have done 1/t of a round. Is that clear? Is that clear, guys? Is that clear, people? Any doubt? You ask me. So this other person was asking me, was saying some other formula. So maybe he was saying it right. Let us just see. So instead of time period, somebody wants to write the whole thing in terms of frequency. What does this formula become? The top one. Wavelength is equal to speed of the wave into 1/frequency. Is that clear? Any doubt? Yes, guys. Any doubt? Have you
No, sir.
noted this? Have you noted this big formula over here? This is just the revision of what was there in class 9. I'm just doing it fast. This holds good for sound wave, any kind of wave. So light wave also. Is that clear, guys? Is that clear? So if I rearrange and write, it comes as a very nice looking formula. What is that? What is that? Speed. Ayyo. What is that? Speed is equal to wavelength into frequency. This is what you are saying, no? Sir? Yes, sir? So all this concept is okay with you guys? Are you comfortable with the word wavelength, speed of wave and frequency of wave? So seldom we talk in terms of time period of wave. We generally talk in terms of frequency of wave. Are you comfortable with this?
Yes, sir.
If you look at the unit, wavelength unit, you can use any unit of length, but we'll rather use meters. And frequency unit is hertz, right? So into hertz means 1/second. Meter into 1/second means meter per second, which is the unit of your speed, right? Right, guys?
Yes, sir.
So cross check of any formula using units is a nice idea all the time. It keeps on going till your highest level of entrance exam also. You keep cross checking your own equations or formulae or everything with the help of units. So this is basics of light, right? Basics of wave, in fact. This part is basics of wave. Is that clear? Is that clear? Now a source of light is sending you disturbances of all kinds. Try to understand that. A source of light. What is the source of light? Maybe a heated object. Okay. Yeah, if object is super cold also it is giving you light, but I'm not getting into that. Okay. I'm not getting into that so that you can relate with objects which you can see. What you can see is what you are calling light, then a rather heated object like a hot rod, your tungsten filament in your bulb, light bulb. Okay. Is that clear? Or any other source of light. What is the source of light doing, people? What is the source of light doing? Emitting these electromagnetic waves of various frequencies or various wavelength. So one big thing I did not ask you, in fact I'll ask you the question and then I'll continue with the slide thing. The question is ba, 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 ba. La, 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 la. Okay, if wavelength of a light is 4, write down as a question, sample question. Hashtag cheap question. Okay, so what's the cheap question over here? Wavelength is equal to 400 nanometers. Is that clear? Then what is the frequency of that light?
Sir, what is wavelength generally measured in nanometers only?
No, it can be anything depending on whose wavelength you are measuring. So if I am talking of visible light and all, no, then they will be giving in say nanometers, such comfortable numbers will come. Is that clear? Is that clear? Guys, you know what is nano? What is nano? Nano? No, 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 no. What is nano? Nano? Okay, what is milli? Guys, milli? Represented by small m. So
That's
millimeter
milli,
is...
micro, and nano.
Milli means what? Millimeter. Mm. You would have heard of that, right? What is milli? What is milli? Milli you don't know.
Sir, 1 by 1000.
Yeah, 10 power minus 3 or 1 by 1000, right? So milligrams even is means what? 1000th of a gram, right? Millimeters means 1000th of a meter. Milli inch means 1000th of an inch. We don't use it that way. Okay, we don't divide inches in what do you say, in decimal system, but still milli inch would mean that. Okay, get the point? What is
Yes, sir.
what is micro?
Sir, 10 to the power minus 6, I guess.
Yeah, absolutely right. So we love in going in multiples of 3. So micro is written by this symbol mu. Okay, that's like symbol what is used. So 1 micrometer, 1 microgram will be how much? 10 power minus 6 grams, right? Micro means 10 power minus 6. You can use in anything you want, right? Is that clear? Is that clear?
Yes, sir.
Now comes your nano. So 1 nanometer.
So 10 is per
10 to the power minus 9.
Yeah. So as your homework, you go and research yourself what is 10 power minus 12, what is 10 power minus 15 and 10 power minus 18. They have named it till there. Is that clear? Is that clear? You already know somebody? 10 power minus 12, can anybody tell me?
So picometer.
Absolutely right. Okay. Chalo, you do it yourself. Otherwise, you'll just listen and forget. If you research yourself, you'll remember. Those who don't research, as such, you are going to forget on listening. So, nano is going to be required over here. For meters, particularly, there is another unit which is very close to this, another span which is very close to this, which is called angstroms. Okay. So, again, you can do your Googling over here. 1 angstrom is 10 power minus 10 meter. Okay. So, sometimes we'll be talking in wavelengths in terms of that. But again, don't worry, that doesn't make the crux of this chapter. We are doing basics of light, and basics of light is something what is, they assume you are knowing, and none of the questions are going to come on this basics of light. Okay. So 400 nanometers, meaning to say how much meters we have told? How much meters? 400 into 10 power minus 9 meters, right? Right, people? Right, people?
Yes, sir.
And I want the frequency. So somebody got the frequency? Did you get the frequency? Did you get the frequency? This is of light. Okay, wavelength of light was given that. So fortunately about light, whatever wavelength it is, the speed is a constant. Is that clear? The speed is the constant of this world, okay, of this universe. What is that speed? What is that value? What is that value? 3 into 10 power 8 meter per second, right? That makes your left hand side. Okay, right hand side wavelength is how much? 400 into 10 power minus 9 meter. Meter will get cancelled, right? Right? Generally people don't write the units when writing the formula because it is little, I made it little cumbersome, difficult to write, but if you write the units also, you are doing it absolutely right. Into F, right? So what unit remains? 1 by second unit remains, no? Meter gets cancelled, then meter gets cancelled, right? 1 by second unit remains. So how much is F with
So
value and
hertz into
unit?
second, right, will remain as a unit.
What?
Hertz into seconds.
Hertz into where is the hertz over here?
So frequency.
No, you don't write the unit of frequency, you'll get the unit of frequency from here. If you write the unit of frequency, if you write the hertz means 1 by second, right, over here, then you'll get just the number, the value. Is that clear? Hertz into second, you don't get hertz into second. You'll get what? This is, hertz means 1 by second, by the way. If you choose to write hertz over here, then 1 by hertz will happen, no, when it goes on the other side.
Yes, sir.
So 1 by hertz second will happen. No, hertz second is nothing. Dimensions cancel. Okay. So the one we are finding, we choose not to write the unit so that we get the unit also out of the formula itself. Okay. Anyways, what do you get the value as? F is equal to how much? F is equal to how much? Like 3 by 4. How much is that? Or you can take 30 by 4, whatever you want to write. 3 by 4 is how much? 0.75, right? Right? Manage
Yes,
the
sir.
zeros. Manage the zeros. Manage your zeros. So what is it? If I choose 4 from here, then this is 10 power minus 7, no? 10 power minus 9 and 100. 10 power minus 7. Goes on the other side, becomes how much? 10 power 7, right? Right? So into 10 power 8, how much is that? 10 power 15, right? Is that clear? Is that clear? Is that clear? Is that clear, people?
Yes, sir.
Yeah.
Yes, sir.
So 10 power 15 units, 1 by second remains, which is your hertz. Simply coming so late. Okay, got the point? Got the point? You see, it is coming such a high value. Okay, it's a visible light. Actually, we'll tell that which light it is in a while. But the frequency of a visible light is in these kind of hertz. That is what you have to know as a general knowledge. That is not going to be taught, and they will generally expect that you know. Is that clear?
Sir, could you go back for a second? I'm sorry.
Shall I change?
No, sir. Just
Okay. Another question as a homework you write. Your Wi-Fi routers. Wi-Fi router. They are also giving you electromagnetic waves. Okay. You can call them as light, but they are not visible light, by the way. Okay. Is that clear? There is no difference between a red light, a blue light, a green light, and the light which is being sent out by the antenna of your routers. Is that clear, guys? Is that clear?
Sir, what affects the
So what is the frequency of those? One second. What is the frequency of those? What is the frequency of those? What is the frequency of those?
5 gigahertz.
Less than visible light.
Yeah, so they have written, they are writing some gigahertz and all, no? 2.4 gigahertz and all, right?
Sir, 5 gigahertz and
5
2.4.
gigahertz, yeah, right? The new ones, right? 5 gigahertz.
Yes, sir.
So what is your giga? What might be giga? Okay, let's climb up the ladder. We had a 10 power We had 1 kilo. Kilometer means what? In terms of meters, just let us understand what is kilo, or forget about meters. What is kilo? 10 power 3 or not?
Yes, sir.
What is 10 power 6? What is 10 power 6?
Sir, hertz.
Hertz. Hertz नहीं बोल रहा हूँ मैं, यूनिट नहीं पूछ रहा हूँ.
अच्छा.
It can be kilometer, kilogram. Okay. So kilo means 10 power 3. What means 10 power 6? What means 10 power 6? You should have heard of it, people. Mega. Have you heard mega?
Yes, sir.
Mega,
Sir,
guys.
10 to the power 9 is giga.
Yeah. Mega, you heard, people?
Yes, sir.
Yeah. So
Yes, sir.
megahertz will be what? 10 power 6 hertz, right? Megameter
Yes,
will be
sir.
what? Hardly used, but megameter will be what? We don't use mega for meters, but still 10 power 6, right?
Yes,
Right?
sir. The
Yes.
1000
Okay.
kilos is 1 mega.
Yeah. Then your giga. Giga means what?
Sir, 10 to the power 9.
Okay. Not gaga. Okay. 10 power 9. Is that clear? So what is this? What are they saying? That the router frequency is 2.4 into 10 power 9 hertz. Is that clear? Hertz is nothing but another way of writing 1 by second. What?
Sir, the meeting is not being recorded.
Now I'm recording on my comp. Is that clear, guys? Is it clear, guys?
Sir, after gigahertz is megahertz, I mean tera, right?
Yeah. Okay, so
And
I just wrote giga over here. You just research on 10 power 3 more, 10 power 3 more, like that. Okay. Do your own research. Okay. Okay. So if the frequency is that, what is the wavelength is my question. So what is the speed you are going to consider?
Sir,
Again same. Why? All electromagnetic waves have the same speed. Write down. All okay, how much is that? Roughly, yeah. So we'll just use the value 3. It is slightly less than 3. Okay. Okay. So 3 into 10 power 8 meter per second. If I write 3.0, I'm mighty wrong. Why? When I write 0.0 means I'm insisting that it is okay 3 and a point, it's 0 over there. Okay. When I write 3, then I am little dicey over here. Is that clear? So when you write here, you are dicey over here. When you write over here, you are dicey over here. Is that clear? So as the standard is growing, your understanding of science should grow. So you should not be thinking in your old fashioned or lower class ways like 3 same as 3.0. It's actually not. Okay. When we talk of reporting values of actual real world measurements. Is that clear, guys? Okay, anyways, chit chat chodo. Ye all electromagnetic waves have same speed in vacuum. Is that clear? Is that clear? Would you be able to do this? Would you be able to do this?
Yes, sir.
Okay. Also tell me whether you are able to see the light coming out of the antenna or not. Answer is no. Okay. The thing is, you can see, human eye can perceive. So are coming to our topic now. Okay. Let us just come closer to our topic. We perceive a frequency that makes up my next question. Sorry, wavelength. We perceive lights of wavelength from around 380 nanometers, depending on how good or bad your eye is, to, can somebody tell me? Can somebody tell me?
Sir, what?
The light, what human eye can detect. Like there's light coming out of your table you're sitting on. You know that? The tabletop is giving you light. Can your eyes see it? Not the reflected light. Like if you are in pitch darkness and your table is giving out light. Can you see it?
No, sir.
No, because it is not falling in the range of a certain wavelength. So what is that range is what I'm asking from your general knowledge. Do you know the
I
length?
think it's around 700.
Yeah, 380 to 780 or 400. No, we'll take it.
So 400 to 700 nanometer.
400 to 800 will roughly take it. Okay. Are you understanding? So for our class, many a times I'll be just referring to say 400 nanometers to 800 nanometers. Is that clear, guys?
Yes, sir.
So my question is, just figure out the frequency range also. Which frequency to which frequency you can actually see the objects which are giving you that frequency light. Is that clear? What is visible to you, right? Visible range. This is your visible range. Can you do that homework? Is that clear? You pick up your calculator, just do the formula. What's the formula? C is equal to lambda f, right? No big deal, right? I think people have done it, would have done it while I was speaking. Anybody has done this? Top one? Top one? Not done. Okay, chalo, chill. Now,
Sir gave introduction in 2 classes ago, 2 or 3 classes ago.
oh, you have done this.
Wavelength is equal to velocity by frequency. He was explaining terms and
Okay, I've done this, guys. Okay, then let us just move on. I'm so sorry. You have done this. Then do that as homework, okay? Okay?
sir, not in that much depth, but he just gave a little bit intro.
Okay, chalo, good revision and some extra things, right? Is that clear?
Yes, sir.
Now, when I say a source is giving out light, which we just generally say as white light, okay, that is a perception by human beings. What do I mean? That source might be giving out, when I say white light, no, it might be giving out all wavelengths, okay, very low to very high. What we have learned till now is this formula. If wavelength is high, frequency will be very low. If wavelength is low, frequency will be high, right? Why? Because the multiplication has to be same. Why? Because it's a constant, right? 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 If I say 8 is equal to x into y, if I take x as say 16, y comes as how much? Half, right?
Yes, sir, 1 by 2.
So higher the x, lower the y, right? If I take a lower value of x, say if I say x is equal to 1, y comes a decent how much? 8, right? Get the point? The multiplication is a constant. So if one is high, the other one will be low. That's easy to understand, right guys? Right guys? Right guys? Respond so that we can go on to the topic, okay? Yeah. So a source of light is giving out wavelength. If we say sun, it is giving out all kinds of wavelength. Whether you can see or you can't see, it's your, that's your problem, your eye's problem, or your eye, I would say, not a problem. But it is giving out all kinds of wavelengths. So if I draw small wavelengths, means high frequency, that's also coming out, right? Very, very small wavelengths, very, very small. Very high frequency means going up and down very fast. High frequency means your time period is very low, means going up down very fast. And low wavelengths, so not going up down so fast. Very, very low wavelengths, very, very low, like the ones you'll find out for your router. Okay, so it doesn't harm us. Low wavelengths don't harm us, high wavelengths harm us. Can you just tell me some names about them? Do you know some names of the wavelengths? Anybody, people?
So can you repeat the question?
Yeah, these wavelengths are called something, like the ones from blue to red is called visible, right? Right? Can you tell me?
Yes, sir.
Ayo. Names, do you know anybody? Nobody.
Sir, I know some.
Okay, tell me. Nice.
Sir, I think there's radio waves, infrared, visible light, ultraviolet, and X-rays.
Where are they?
I
Where are
don't-
they? Where are they?
Sir, radio wave is the smallest.
Smallest what?
Smallest, no, it has the shortest frequency. It has the least
Short.
amount of frequency.
Short frequency. Do you
No, it has the
Use the-
most frequency. Sorry, sir. The shortest period. My bad.
short period? Sure. Are you sure?
Yes, sir. I'm
Or
pretty-
what are you
no.
saying?
1 second, sir. Now I'm confused, sir. 1 second.
Okay, so let me just tell. Let us just go
No, sir, it's the other way
beyond
around.
this. Let us just go beyond this. Okay, very very high frequency. There are a lot of names. Okay, I'm not going into all cosmic and gamma and all, but the ones which is very very common. High frequency, very high frequency, so very low wavelength. X-rays. High energy, you'll have a formula based on energy and frequency in a higher class. Okay? Is that clear? X-rays, very low wavelength, very high frequency. What is it? High F, low wavelength. Is that clear? Is that clear? Very dangerous. Higher the frequency, more dangerous it is. What would this be? What would this be? Say ultraviolet. Quite dangerous. Okay? UV. Shall I write ultraviolet? You can write, no? You write the whole thing, ultraviolet. Okay? Is that clear? Is it visible to you? Not visible to you yet. Okay?
No, sir.
Where do gamma rays
Then
come in?
comes your violet or blue or whatever. Okay, you come into the range. Okay, so you have your VIBGYOR happening over here, right? Right, people?
Sir, do gamma rays come in this?
Gamma यहाँ पे, X-ray से भी higher frequency. Okay, even higher than X-rays. Okay, so this is your visible. Is that clear? Starting with violet and ending in red. ठीक है? ठीक है?
Yes.
ठीक है? Then higher wavelength than that is what? Higher wavelength than that is what? Quite less dangerous. What is that? Infrared. You write the whole thing, infrared, IR. Okay? I'm writing the short form. You write infrared. Then higher than that, people, I hope you know this. Microwave. Microwave. Even higher than that, radio waves. Okay? And the frequencies what we have is they are called radio frequencies. Okay? So all transmissions and everything happens on radio frequencies of various, like it's a range. Okay? So they are the least dangerous, highest wavelength, lowest frequency. Lowest F, longest wavelength. ठीक है, टीवी का सिग्नल, रेडियो का सिग्नल, your mobile phone catching a signal, your Wi-Fi routers, all will come in this. So every day this signal is passing through you. You swallow your mobile phone, it is still going to ring in your tummy. Why? It goes through you, right? These wavelengths goes through you. Is that clear? You are inside your house and you can open the door of your car by the radio frequency in the car key, right? How does it open? It is shooting out a light. That light we call it as radio wave, which goes right through the wall. Why? Because they are long enough to shoot through that. And this is the concept what we are going to come to. Are you getting the point? Which is happening every day around you, but you have to understand that. Is that clear? Is that clear? So, if the wavelength is in a particular slot, not higher, not lower, then only your eye, as a human eye, is able to detect it. So, can there be some animal which is detecting IR also? There can be, right?
Yes.
Can there be some animal whose eye is detecting UV also? There can be, right? ठीक है. अब अर्थ पे है, all species which has grown is under sunlight and all, and most probably they will be all around the same wavelengths, but wouldn't be exact. No, two humans का भी exact नहीं है. The blue what you call and the other guy will be calling it the same blue, but they are actually perceiving it differently. A whole good paper is on that, but again I am not getting into that. Is that clear, guys? So this is your whole light. This is the light spectrum. It's called the light spectrum. Is that clear? Out of which your visible spectrum is what? What is your visible spectrum? From here to there, right? Right? You have any people in your family who can't see a red? Who can't see red properly, it becomes grey for them. Okay, anyways, I'm not going to talk about the rods and cones in your eye. I don't think it is in course. It was in course, but they have removed it. So this is your visible spectrum.
Sir, is that a condition called color blindness?
Could not hear, say properly.
Sir, isn't that a condition called color blindness? Where we
Yeah,
aren't
color
able to
blindness
see
is
that?
there, right?
Yes, sir.
So it is not like you have to be totally color blind. Let me just draw this Vibgyor over here. Vibgyor. Okay. It's written in a way such that it is easily readable, but if I have to pick the middle frequency is this yellow. So don't look at the middle letter of the whole word. Is that clear? Is that clear? Okay. That's your middle frequency. So it will be roughly where 400 plus 800 by 2, 600, no? Right, guys? Nanometer, right?
Yes, sir.
So this is the brightest for the human eye. Remember the movie PK? He is wearing a red helmet, he says, so that it is easily visible. Okay? Meaning to say, if you have 3 flashlights which gives out the same power, one is red, one is yellow, one is blue, then the yellow one is going to be the brightest for you. Over here also, can you just see that yellow might be looking brighter for you?
Yes.
Okay, because that's the brightest for human eye. Okay. Okay, anyways, so this is your visible spectrum. Okay. So towards the end, one is able to see as a red, just like the edge of the red, and the other guy is not able to see, is absolutely okay. Like when we say that we are hearing 20 hertz frequency sound to 20,000 hertz, do you think each and every person will be able to hear this 20,000 hertz? No.
No, sir.
सबका कान सेम जैसा नहीं है. It is all human dependent. Okay, so it's not like a rigid thing over here. Okay, but when you cross say 450 hertz and you go almost to say 700 hertz, most of the human being will be able to see. कुछ एंड का रेड ग्रे दिखेगा नहीं दिखेगा, that is another problem. So we have say somebody is slightly color blind, so maybe red is gone for him. The extreme violet colors, extreme end of the spectrum, some are able to see, the others will perceive it as gray only, will not be able to see. ठीक है? The cat whose range is mostly towards that, shifted towards the blue, maybe the blue side is the brightest for the cat. Okay, is that clear? Okay, so don't go by numbers as very rigidly. Understood what is a visible spectrum? Is it clear, people? Is it clear?
Yes, sir.
Okay, one last thing I'll just tell as a general knowledge before we start understanding the phenomena. If there is, because this, when people are coming for the classes, no, I generally walk in the class and show. Okay, so if there's a man, tall man, okay, I'm not tall by the way. If there's a tall man who is walking with a child, the child is small, the steps will be also small, right? Okay, but they are walking together, so what is their speed is together, right? Speed is same, say they are walking at 2 meters per second. So how do you fancy they are walking? The big man is taking such steps, suppose, and the child would be taking what steps?
Sir, smaller.
Small steps, right? Right? So
Yes,
the longer steps will be taken at lower frequency or not? Like it will consume more time to take that step or not? Slowly, right? One step, then the other step. In that time, this guy has to take 3 steps while the other guy takes 1 step, right? Right?
Yes, sir.
So these steps are your wavelength and the number of them you are taking is your frequency, right? This wavelength is large for the man, but the frequency has to be small, right? Large for the man, small wavelength for the child, but the frequency of the child will be 3 times more than the frequency of the man. Is that clear? Is that clear? So when you look at them, no, who seems more energetic? The boy seems more energetic, by the way. Okay, duck, 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 he is taking. Okay, are you getting the point? Almost same thing with the light. I can't walk over here and show it to you, otherwise it would have given you some effect. But anyways, are you getting the point? What is the difference between your, I mean, what is, how does light behave? All these wavelengths are having same speed. One are going at a easy, I mean longer steps, lower frequencies, and the others are going at duck, 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 lower, smaller steps and very high frequencies. Is that clear? Is that clear? Is that clear? Is that clear? Is that clear?
Yes.
And all objects in this world which is above 0 Kelvin, meaning to say minus 273 degree Celsius, all objects in this world is giving out the light, but they are giving out light in a range which is not visible to you. Is that clear? Human bodies are hotter than the objects around, so we say that we are giving out light in infrared range. When we calculate, it is infrared. So one can see human being in the dark also using IR cameras or not? You would have heard of that, no? Military using infrared cameras, right?
Yes, sir.
Because why? We are also like glowing bulbs. We are actually like glowing bulbs. But the light of the bulb what we are giving is not visible to another human, but we have made cameras through which we can see. Is that clear? Is that clear?
Yes.
Okay, just last question, if is it clear to everybody? Blue is more dangerous or red? Blue is more dangerous or red?
Sir, blue.
Absolutely right. Okay. I'm asking you this because generally they associate red light with danger, right? Right? So we'll come to that, why they use red light for danger. Okay. Red is the coolest light for anybody. Okay. Red is the coolest visible light. And blue is the hottest visible light, and mind you, we represent blue as cool, right? Right?
Yes, sir.
Yes.
थोड़ा सा blue से थोड़ा और उधर जाओगे ना, and it is ultraviolet, it is dangerously bad for us. Blue is also bad, but ultraviolet is, or violet is dangerously bad. Get the point? Red is the coolest for us. Okay. So what about microwave? Is it more energetic or ultraviolet more energetic, or blue light, like normal blue light more energetic, or microwave? Same intensity?
Is more
Blue, right? So microwave we use in a microwave oven not because it is dangerous or it is having energy. We use it for another reason. One of the reason is because it is not so dangerous. Okay, that is one of the reasons why we use it. How we use it? Some other class, not in this class. Okay, okay. So are we set for the chapter? Is it okay? Have you got an idea of what all things are? Is that okay?
Yes, sir.
You want to ask anything? Ask. Do you want to ask anything? You have noted down the in between questions?
Sir, like there was this person like who could like slow down the speed of light in vacuum.
Who could?
Like there was an experiment like slowing down speed of light in vacuum by using ultra cold active clouds.
Okay.
Yeah. So like, is there a way like in which we can just bring the speed of light, like the light at absolute, like very slowly, that we can actually see it by our eyes, and then like see what is happening in light?
I mean, through theoretical experiment, if somebody has done it, I have not read the experiment. But as theory, we are going to see how we slow down the speeds, which you already know, no? Like in theory. How do you slow down the speed? Hello?
By getting a denser medium.
Yeah, when you go to a optically denser medium, right? So to create a optically dense medium by making a ultra cold cloud is a good idea, right? So if somebody is able to slow it down to that level, good for the world. Okay. I have not gone through it. Is that clear?
Yes, sir.
Okay. How it slows down and why it slows down is because of how light electromagnetic waves interact with the electron cloud. So that study, I think 12th में जाओगे तो फिर तुमको ज़्यादा clarity मिलेगा. Then I can discuss the very same topic in little more detail. Okay. Why it actually bends, or why a light in a medium actually slows down. ठीक है ना? What it is doing, how it is resonating with the electron cloud which it is passing through. All that we'll do after we have more understanding of the basics. ठीक है? चलो, इस basics all clear guys.
Yes, sir.
ठीक है, चलो.